I am Mary Olson. I work for Nuclear Information and Resource Service, which is a national organization. I am based here in Asheville, and my comrades, my coworkers are all in the Washington, D.C. area. And I'll just say that I think it's extremely important to be able to share the information that I'm about to share. It's important for women, it's important for parents, important for partners, important for sisters and brothers. It's important for all of our society to have this information, which unfortunately is not widely available. So, talking about atomic impacts, radiation. Why do people split atoms? The simple answer is heat. We kill people and destroy landscapes with the heat, the fireball of the atomic explosion. We use the heat of the reactor to generate steam, and the steam is just like Watt and stationary steam of 200 years ago, no different, and the massive amounts of heat are released to our environment. But there is the enduring outcome, which is harmful radioactivity, which in both cases is secondary to the reason anyone set out to do the splitting of the atom to begin with. This timeline shows up above about how long scientists say we've been around as a species. Down below is the half-life of one of the longer-lived plutoniums, and I added the red arrow at this point because that is the half-life of plutonium-239, the dominant element in nuclear weapons, produced in nuclear reactors, and that's 10 half-lives of it, so 240,000 years. So, a key point, young people today do not hear from any authority figure that radiation causes cancer. They hear it's a treatment for cancer. They hear that they can have their teeth fixed better or their shoulder fixed better with it. They get a lot of mixed messages from Hollywood. But the fact is that ionizing radiation, the stuff from splitting atoms, here's an atom being split, produces particles that can impact living tissue, not just human beings, any kind of living tissue, can damage the cells, particularly the DNA, which is the strand in the middle, which leads to a possible cancer cell. Not in every case, we have natural repair mechanisms, not every emission causes damage, but that's the basic thing. That cancer cell can sit there for a very long time and eventually become a tumor. So I'm going to go pretty quick now through some images. This is very high radiation. You can get burned. This is plutonium in the lung. The starburst is dead tissue where the alpha particles are killing the tissue. This is a picture by an artist that shows that there's multiple ways that radiation can harm DNA, and there's multiple outcomes that we'll talk about. Oh, but I should just say that when the DNA is coiled, then it's called a chromosome. When it's uncoiled or open, that's where you get the strands, and that is when damage is more likely to happen from nuclear emissions. So again, we can see the harm. Radioactivity is invisible. We can't see it, we can't hear it, we can't smell it, but we can see the harm. Ripped cell membrane is possible from an alpha particle. And again, chromosomes themselves can be physically broken and damaged. And when that happens, you get multiple different outcomes, including dicentric, where two centers have come back together, where a break happened, and now there's two centers. You can actually, on higher doses, measure how much radiation people have had by the dicentric chromosomal aberrations in their white blood cells. So, different types of damage. This is a little bit nerdy, but I want you to know that when they talk about radiation, they only talk about ionization, which is where you knock off an electron, and now something that used to be neutral charged changes. So it's an electrical disruption and a chemical disruption. However, there's direct physical damage. I just showed you the pictures. The particles can hit and break cellular structures. That's not talked about when they calculate radiation dose and radiation hazard. It's just left out. Then there is the disruption of natural DNA repair. We have repair mechanisms. If they are disrupted, then the cell is damaged in a different way. And epigenetics is a big category that's growing by the day. I can't tell you that much about it, but it's the non-DNA impacts. In other words, there's a lot of other things in our cells besides DNA that can be damaged. And one of my teachers suggested that there may be subatomic impacts from radiation down at the level of quarks, that in fact radioactivity may be affecting the field generated by matter in a way that's different, and that's part of the disease-causing mechanism. So, just to take this to a more bigger level, we've been talking about the cellular levels.
You're saying that it generates harmful energy.
Yes, but that is still a hypothesis. It's not yet proven. So taking to the body level, what do we get? We get defects, we get disease, we get cancer. If any of these are in the germline, meaning an egg or a sperm, that can affect future generations. If it's in the somatic part, our own body, that's where we get cancer and disease that's in this generation only. So when you talk about it in a reproductive context, you can do harm to an embryo, and if it's really severe, the woman probably doesn't even know she was pregnant. She has a spontaneous abortion, and it can be caused by radiation. This happened to the birds worldwide from Chernobyl. Harm to a fetus, if it's very severe, leads to a miscarriage, and also can result in mutation that's specific to that one child, or can actually be heritable if it hits an egg or a sperm. In other words, the germ tissues. And it can also become the somatic basis for cancer, which, when that happens to a developing baby, we call it a post-birth defect. Childhood cancer can be rooted in exposures that happened before they were born. And then again, the non-DNA damage. And this is really important. People don't remember that I was an egg in my mommy when she was not yet born. My egg, and men are coming from eggs too. It's not just girls that come from eggs. You have to have an egg and a sperm for every child. He was in his mommy's ovaries while his mommy was in his grandmommy. So the non-DNA effects are understudied, understood, but very important. So we get to Chernobyl heart, a defect that is very common in the areas around Chernobyl because of exposure to radiation. Again, in that same area, more studied than Fukushima is yet. We're going to hear more about Fukushima soon. But Chernobyl AIDS, also called failure to thrive. The immune system is overtaxed and doesn't work well. And we really don't know that much about heritability because in the societies where there have been large numbers of people exposed, the victims have been shunned. And the medical communities have been suppressed and told, no, you can't report that as radiation effect. We have virtually no information about second, third, fourth generations, whereas we have them out there. Oh, and the reason I put down Lucille and Muller is that these are two researchers who said, well, let's look at short life cycles where we can actually look at it ourselves, birds, bugs, small rodents, and they've been studying around Chernobyl and around Fukushima now. And they are finding many, many mutations, some of which are very devastating to the organism and are moving out in space and also in time and generations. So those questions are being answered in the non-human population. But the bottom line here is that when we come to talking about the regulators, the federal agencies that enable these activities, these industrial scale activities, whether they be bomb making or whether they be nuclear power, whatever they are, they only look at cancer. I've been talking to you for 6 slides about all the different things that come from ionizing radiation exposure to living tissue. The only one that counts is cancer. So, do you live near a nuclear site? I have big maps I'll show you, but this is the big commercial and military complex. I'm going to whip by it. Here's the same map done by some Grey Panthers who were the first to combine local, state, and federal bases of information in a database still on Ellen's website. So how close is close? 40 miles from here in Irwin, Tennessee, you can see the backside of the nuclear waste processor with some of the hottest so-called low-level radioactive waste in the nation. And this is a carport. And this is a wooden fence, which until recently was only a wooden fence. Now there is a concrete barricade as well. But it's only about as tall as me, that barricade. How close is close? Clearly, Japan has a lot more contamination. That's what this picture is. Japan up into Russia, Alaska, down to Canada, western coast of the United States. The hot spot is here, but the impact is clearly quite large. Here is what happened in 10 days of fire after an explosion in Ukraine. The reactor is in this hot spot area right here, and that is what happened to Western Europe and Russia. A little bit of the Middle East. And then, of course, we set off hundreds of nuclear weapons in the air in Nevada. And this is a very picturesque thing. There are not very many compiled pictures of the actual fallout from US weapons tests. But it's worth noting that the Queen of England said, no, you can't test those things on the East Coast, because they didn't want the fallout in England. So we got it nationwide, delivered to our doorstep. And then I just want to note that it doesn't take an accident. At a reactor, they open the vessel to refuel and for various maintenance reasons. Each time they do that, there's a spike of radioactivity that's measurable in the area, not just on the site, but in the communities around it. And the same happens when they do planned releases. Just because they're planned doesn't make them not releases. And they're allowed to average these things over a full year so they can meet the regulations, even though during that time you would get a much higher dose. So this is a standard picture they give you from the government about how all this stuff travels in our environment, admitting that they allow releases to air, water, food, the food chain, concentrates radioactivity, so that you get more by eating the cow than by eating the grass. And then this is crucial. They do show a man, because all of those standards are written assuming a standard man. And that's because the nuclear age was founded on the Manhattan Project, building the nuclear bomb to beat Hitler and nuke Japan. And the people they were sending into the Manhattan Project areas were all military and paramilitary young males. But they took those standards and they generalized them to exposing the entire population without the benefit of what you're about to hear from me now. The first is that internal exposure by eating radioactive food, drinking radioactive water, breathing radioactive air is totally different than external exposure, and it also is not factored. Just like only cancer is factored, internal exposure is not included in most factoring of the standards and whether they've been met or not. So, what factors make a difference in when radiation is released and people are being impacted? What are the things that make a difference between people? First thing we know is that children are more vulnerable. Their bodies are growing, their cells are dividing more rapidly, their body mass is smaller. The same amount of radioactivity is going to give them a larger dose. We know now that genetics are specific, that some family bloodlines are more resistant to radioactivity and some are more vulnerable. And it may have more specificity than that, but we don't really know yet. We do know that lifestyle makes a difference, that synergy of exposures. If you're a smoker and you get plutonium in your lung, it's probably worse, or uranium in your lung, that kind of thing. Lifestyle has a role. And we also now know that gender matters. So I take the title again because I've kind of given you the framework in which we know about radiation, but I had started getting questions at events like this one in about 2010, 2009, women raising their hand and asking me, isn't radiation more harmful to women? And I had never heard this. I kept coming back with, you mean pregnant women, in which case we're talking about the fetus and the embryo and all that, you know? No, women. So when Fukushima happened, I knew I could not show up in the discussion on radiation without tracking down the basis of this question. And I went to Rosalie Bertell, one of my teachers who wrote this book, No Immediate Danger. The question mark fell off. Never ever repeat the lie is what she said after that. But very important baseline text on human health and radiation. Rosalie was towards the end of her life, and she said, well, it's in the National Academy of Sciences report, but the authors don't mention it. You have to look at the numbers. So that's the cover of the report that she was directing me to, that is from the National Academy. And I'm just telling you, there's lots of numbers in there by putting these slides in. Now there's a problem with using this report. I feel like a war criminal when I do, because where did the numbers come from? Primarily the survivors of the first strike attack by the United States on Japan at Hiroshima and Nagasaki in 1945. So it becomes a laboratory, because the assumption is, anyway, that a large group of people was exposed to a single flash of radiation, and depending on where they were at the time it happened, they were either vaporized, in which case they're gone in that huge fireball I showed you, or they had some amount of radiation dose. And so they've assumed that without any fallout, which is somewhat controversial, there may have been fallout, there may have been internal exposure as well, but they've assumed only external exposure. And the other issue is that the data collection began 5 years after the bombs. So the most vulnerable people were already dead. Now, the war crimes part, aside from the war and the crimes and all that, you can really go into the whole Second World War stories and what does it all mean, and different people believe different things. But people went into Hiroshima and went into Nagasaki for purposes of studying the survivors without offering any medical assistance at all. That's what makes me feel like a little bit of a collaborator to use this report. So I'm just laying that out there, that it's hard to do this. But they were there to be bean counters, to see how many people died. I'm inviting people, I wish I had copies of this here, but there's a wonderful film that Kathleen and Robert did called The Ultimate Wish Ending the Nuclear Age that tells the story of survivors in Nagasaki as well as Fukushima. So, going back to the numbers, Rosalie said, I said, okay, I'll be brave, I'm not good at numbers, I'll look at them. I had to crunch them in various different ways, but what it comes down to is that men and boys get sick from radiation. They are not superheroes who, like, it all bounces off, okay? Men get sick from radiation. Little boys get sicker from radiation. But girls, compared to boys, at the same dose level, get twice as sick. And this isn't only while they're little girls. This is radiation, and there's latency periods, and so it's over their entire lives. Girls get more cancer over their life from an exposure in childhood than boys. And it's a pretty big difference, twice as much. That's 100% difference. So then when you say, okay, we didn't expose them as little kids, they were adults when it happened, it's still 50% more cancer for women than for men. So 2 men get cancer, 3 women. Because I don't like talking about half people, so I go to 2 and 3. You can do 4 and 6 if you like, whatever. 50% more women get cancer compared to men. So I wrote a paper, it's online, I didn't make copies of it for here. Arjun Makajani did some great work on the children's end of this that I was unaware of at the time that I called Rosalie. And then there's this slide, which we're going to take apart for a minute, because some people understand graphical presentation of numbers, and for other people it's really scary. But this shows the males on the blue line, and females on the pink line, and the ages at the bottom from 0 to 80. And this is how much more cancer. So there's cancer in our population. So this is how much more cancer the scientists believe the radiation exposure caused. And so it's at different ages. So I'm going to take this apart a little bit further. First, we're going to look at just the left end, because this is where the really big difference is. You can remember that blue is boy and pink is girl. That's easy. So here is about 500, increase of 500 cases. And that's almost up to 1,000. So it really is double, and it's that 0 to 5 age group. Now, it's increased, but it's age of exposure. So the cancer may not occur between 0 and 5. It may occur at some other point in their life. But a girl is twice as likely as a boy. Now, just quickly taking this piece of it. Let's say you're a regulator and you don't look at that young end. You're just looking at this reference band. That's the green circle. Yeah, there's still a difference between boys and girls. At this point, it's 30 years old, roughly 28. So, you know, this is that 50% more roughly if you kind of measure with your eye there. But it doesn't tell you that real story that you get when you look at the whole thing together now. And this is the numbers from the National Academy of Sciences. It's from Hiroshima and Nagasaki primarily, but there's some other studies used to corroborate it. There is an assumption of external dose only, and this is the first time we see a picture over the entire life cycle of the human being. So it's really important.
What causes the twice the amount when you're so young, say when you're 2 years old? What is the difference at that point?
Isn't it interesting? Because if we said just men and women, you could say, oh, women are generally smaller, men generally do these other types of activities, you know, there's hormonal differences, there's this and that. But when you're between 0 and 5, there's not much lifestyle difference, there's not much size difference, there's not what? So that's the next course. We need to raise a generation of women who will tackle this question and get the answers done. But Rosalie's hypothesis is that the reproductive tissues are more hot, they're more sensitive to radiation, and so the female body has that much more reproductive tissue in it compared to just the gonads of the man.
Even when you're 2 years old or 3 years old?
Yeah, the percentages of your body. And they're going to mature, and so if they're exposed when they're not developed, then the vulnerability may be greater. But there's too many things. We can't say that's the reason. We can say that's Rosalie's idea. So I have this handout to give people, and I'm about done. But being invisible in our society has real costs. We are invisible in the nuclear regulatory structure. We are not there as who we are, which is the ones who should determine this, because we're not a subpopulation. I caught the Environmental Protection Agency calling little girls a subpopulation. I said, wait a minute. Little girls in Chicago, that's a subpopulation. Little girls, that's life cycle. You cannot get to a standard man without a little girl. So the point here is we suffer more, but we don't set the policy for the most part. We're getting more women in more places, but we do not have decision-making hegemony yet. So here's one of the final points that I can't really unpack, but we've been getting ready to make comments to the Environmental Protection Agency because they're revising the radiation standards, and I brought a simple one you can fill out and sign, although you're welcome to use the address to send your own, but the deadline's coming. Anyway, we've been working on it, and it turns out that if you take that juvenile female as that green round circle as the reference point and say, we're going to build everything to protect that little girl, you can't do it. The additional annual doses go negative, which means one thing. My bully pulpit has been correct. We have to shut them all down. We have to clean them up. And if we clean up, we will be producing an annual additional dose, which is negative because people's doses will be going down. And that is when we can protect the little girl, not before. So they really shouldn't have the name Environmental Protection Agency. They're just giving licenses to kill.
That's correct.
And I already made the subpopulation point. You've already seen this slide. Oh. Remember the magician, and they have the girl and the dove and the scarf and the flower. And so like this picture of how much radiation people get every year is pretty common. They put it in lots of places. Well, this is the girl and the dove and the flower, and we could go into it, but if you do that, you can actually see the natural background is this pie, and man-made radiation is this slice. And if you take this slice away and say pre-Madame Curie, and just look at this picture, that much is a 25% increase in radiation exposure to the general population in only 100 and some years. So if you did anything, a 25% increase, whether it be temperature or the amount of sunlight or all kinds of things that you can imagine as an environmental parameter, 25% increase. That's what has been accomplished, and that's what we're up against. So I did a poor job. I've been trying to find the one that somebody did a great job of. This is the new International Radiation Symbol, which is much more explicit. Thank you. Danger, skull and crossbones, man running. Well, somebody's done a great job of making it a woman and child running and making them run even faster. So, thank you.
Thank you. All right.